Alright guys, sorry for the delay. So this is the CS100 review session. So I listed out some topics here that I want to cover today, and you guys could let me know if you have any others that you'd like to see covered. We're gonna go over files. We'll go over dictionaries. We're going to go over lists, control structures, we're going to go over loop conditions, we're going to go over turtle questions, we'll go over booleans. We'll go over some strategies to use for the programming part. We're going to go over user input. We'll go over data type manipulation. We're going to go over strings. So basically some methods we could use on strings, how to format strings, stuff like that. Errors, or as they're called in Python, exceptions. How to trace code so that we get the right answer for the multiple choice questions. Common mistakes. So how to avoid the common mistakes made by a lot of students on the tests. We're going to go over scope of variables. We'll go over print versus return. Functions and parameters. And sets and tuples. So guys, feel free to comment if everything else. Yeah, so definitely yeah, you could unmute if you want to ask a question. And so if everyone's okay, then we'll keep moving forward. So I'll just clear our space here. So these are the topics right now that I plan on covering. So let me know if you want any other topics covered. Also let me know if you could hear me, and as long as everything is going well so far. Hopefully all you guys could hear me. Alright guys, so we're going to start off today with lists. So lists. I'll just zoom in here just to give you guys some more, just to give me some more space to write. And just so you guys could all see it. Alright, as long as everyone's doing well, we'll keep going. Okay, so lists. So lists are a group, well, the definition of like a list. So a group of elements enclosed in square brackets and separated by commas. Alright, I'll just move this stuff out of the way just so we have more room. Okay, why all these boxes are here, I don't know. Okay, good, we're good. So a list is a group of elements enclosed in square brackets and separated by commas. So remember that you could have a mix of any data type in there. So unlike, in other things such as Java, in other programming languages like Java, C++, the arrays, which are the equivalent of lists, have to contain only one data type. Python's different in that we contain any data type and any mix of data types in our lists. Additionally, so an example of a list, you guys know this already, but we could say I5G. So this is a list. We have strings, we have an integer, we could even have, a floating point. So some of the things we could do to a list, or the methods we could call on it. And this is actually a great time to bring up, you guys were all given like a cheat sheet sort of on the exam, like 2 pages of like methods and stuff, so definitely make full use of that. So we have, let's say LST was our list, we have lst.append. So remember, this is when you want to add something to the list, and then you'd have the thing you want to add inside of the parentheses, right? lst.count. So count how many times an element occurs within the list, and again, this is like the item you want to count. Okay, item you want to append, item you want to count. lst.index. So to get the index of this item here, basically remember, so we start indexing at 0, right, and we go on from there. So that's an important point to note, that remember index, so position in the array, so the list. So if we have 3 elements here, right, the index of this would be 0, but the position is 1, right? So just remember that, index is always position minus 1. We have lst.insert. So just remember, lst just stands for an arbitrary list that we have. So insert, and this would be, the item would be the first argument, and so this is the item. Oh, sorry, index. The first argument is the index, and the second argument is the item. Okay. We have lst.pop, lst.remove the thing with the item, lst.reverse, and lst.sort. So far, so good. Okay. So, for instance, if you use the PowerPoint medium. Yeah, so basically, so this is being recorded, guys, so that's how I figure I'll distribute it later. I guess we could also do some PowerPoint, but I figured Photoshop was the best, just so it kind of be like, so I had space to write and stuff instead of just typing it. I'm using my tablet here. Alright, so we'll just clear this off and give ourselves more space. Right.
One thing, isn't there a remove at index method for the lists or something like that?
Remove at index? I think remove, we can actually check the Python documentation, but I think remove can take a optional parameter with actually removing at a certain index. Let's see. So the question posed was if we could remove an element at the given index. And so this is how you remove by a value, list.remove. But let's see if there's a way to remove at an index. Okay, so pop.
I think it's just pop. Yep,
yeah, if we give pop the index, then and if not, it'll remove and return the last item list. Okay, cool. Yeah, guys, definitely. If you have any questions, definitely don't be afraid to ask them. Okay. Okay. Once it's sort of off the topic of lists, but one thing I wanted to point out: just be careful with division versus integer division. And this is integer division. So just remember, this is like the regular division, and integer division, right? These should be slanted. That's always gonna give you an integer back. So that's just one little tidbit of information. Now we're gonna go over conversions of types. So we have bool, int, float. So remember, we have the boolean, which is contained, right? That's the smallest of them. And then we have the integer, and then we have the float. So remember, one thing about this is that if we go this way, conversion's not okay. So remember, we could take a bigger thing and make it smaller, but if we take a small thing and make it bigger, sometimes it works, but sometimes we can run into errors. For example, converting, right? If we convert from an int to a float, it could result in an overflow. So just be aware of that. Now, this probably isn't applicable for the test because none of the numbers you're going to be working with are that large, but just remember for the future as well, if you try to go from int to a float, be careful with your values. So that's one thing to watch out for. And just also to be aware of that error for the test, just in case it happens to turn up. Okay, so one thing is also passing parameters. So remember, if we're like defining a function, we'll just abbreviate here, and then you have the parameters. Let's say you have one parameter and another parameter. So here, remember, they're called parameters. These are general things. So if we have I and A, let's say, down here we would refer to them as I and A. So I dot, remove. Let's say I was an array, list. Sorry, and we wanted to remove something, and A was, let's say, a string. So we do all that stuff here, and then when we passed in a value for this, remember all of the code. So now we pass in a value, right? And the values we pass in are called arguments when we call a function. Once we passed in that value, when this function's called, it's going to do all the things that it said it was going to, that we told it to do to I, it's actually going to do to this value. So that's the whole concept of parameter passing. So now we're going to go over strings. So strings. And I know strings are pretty basic, but there were some more advanced topics covered with regards to strings. I believe it was like before or after the second midterm. So we'll just review some of those because, you definitely have to do some stuff with strings on the exam. So strings, remember, they're just a sequence of characters enclosed in single quotes or double quotes. And remember, you can also have triple quote strings. But for this review, we're just going to focus on like single quotes or double quotes, just to keep it simple. So we have some methods that we use with strings. So my main goal here with telling you guys the methods first is just then when you're using that cheat sheet, just so these are like fresh in your memory, and then we'll go through some more of the other topics that are a little that are going to be like less intuitive or less specific, I should say. So string 1 dot capitalize. String 1 dot count. And when I put this line here, that just means we take in an argument there. String 1 dot string 1 dot find. String 1 dot lower. String 1 dot replace. And here the arguments get a little more important. The old thing that you want to replace goes first, and the new thing that you want this thing to be replaced with goes second. So this is going to replace this. So that's just important to be aware of. So that's important. That's important just because we're not just passing in one argument there, as we are on most of the others. string1 dot split, and what we want to split by is given here. If nothing specified, it's the empty space is the default. String1 dot strip and string1 dot upper. And I believe this at least has an optional argument. So those are our string methods. So again, I'm just going to clear off this space now. So that's what we've done. So we've went over division and integer division, problems with conversion, and strings so far. Okay. So if everyone's good with that, we'll keep moving forward. Okay. So, okay, one quick thing I wanted to go over, another thing with strings. So formatting strings. Specifically the dot format method. The reason this method is a little different, it does things, there's a little bit more than just an argument that's passed in. So basically, if I give you an example here, we have this single quoted string. So this notation is a little bit different than what you may be used to seeing. That's why I wanted to review it before the test. Dot format 0, 1. Okay, what we have here, these two arguments are what we're passing to format. I called the variables 0 and 1. That's just to indicate that this is the 0 at the 0th index, 1 is at the first index. Just to make it seem more logical, so when we pass these variables into this format method, right, remember that the notation is that this, whatever's here, will be replaced by that, and 1 will replace this. Now, one other thing I wanted to show you was, let's say we had 1 here and 0 here, and we did format, and we gave the arguments 0, 1, right? So remember, the number here is denoting the index of the variable within the parameters that we want to replace. So basically 0 now goes to this one, so the thing at the 0 index goes here, and the thing at the first index goes here. So that's an important distinction. Just be aware of that. I'm not too sure if it's going to show up on your test. You may want to use it on one of the coding questions, but just in case. That's always a good one to know. Now this is definitely going to show up on the test in some form or another. This is file, input, output. Okay, so there's 3 steps when we're working with files. Open the file. Now 2, this is pretty important because there's 2 distinct things, whether we're reading or writing to the file. So if we're reading or if we're writing. So if we're reading, we're going to do one of 3 things. We're going to use either read, ReadLine, or read lines. Okay? Writing, we're going to use .write. So either way, and inside of .write is going to be the string that we actually want to write to the file. Okay. And now, 3rd step is going to be close the file. So one thing I wanted to point out, so opening the file, you have to open the file whether you're reading or writing to it. So this is universal right here. In other words, regardless of whether you're reading or writing to the file, you have to open the file. Then you have to either read or write to the file, depending on what you opened it for. And remember, to open a file, to read, that's the default. You could also specify this as one of the parameters, and write would just be specifying this. So it would be like the file.open. I think here's like the file name, and then you would say either read or you would say write. There's also append, which just means, write wipes the file clean. Okay, so this is important for the test. It might be, if it shows up on multiple choice especially. When you write to a file, you wipe the contents. You start, so here's the file, and we've written these lines, right? When we write to this file, right, then we turn around and wipe this content. So we start back here. See what I'm saying? So in other words, when we append to a file, right, let's say we ended here when we were writing to the file. If we append, we're going to start here and we're going to continue writing. However, if you use the .write method, then you're going to start here again at the beginning of the file. So you're going to wipe all of those things that you just wrote. So hopefully that's clear with everybody. If not, definitely let me know and I'll repeat that. So we have read, readline, or readlines. So let's look at all these things in greater detail. What's up?
Can you please repeat that?
Can I repeat? Oh yeah, sure. So we're basically talking about write versus append, right? So if we have this here, if we write 2 lines to a file and we append to that file, we open the file for appending, which means when we do .open, we specify the file name and then append, right? Then we add. We're going to add right here. So the indicator, this is like the cursor where we left off. We're going to add to that. Now, in contrast with that, I'm just going to clear a little space here. That's the one annoying thing about working in Photoshop is I have to keep, clearing space. But now if I do this, okay. So now we left off here, right? So now if we use write instead, so we use .open and we specified write, then irregardless of where we stopped, that doesn't matter. We would start back at the beginning of the file, we would write, and anything past that would be wiped. Right? So all this is gone. Right? So we overwrote that file. In other words, when you open a file for writing, you're overwriting that file. You're overwriting the contents of that file with whatever you put. When you append, you're adding to that. So it all depends on what your goal is, basically. So is that clear? Everything that better? Okay.
Yeah, thanks.
Yeah, no problem. Definitely, yeah, guys, definitely stop me if I'm going too fast or if I'm not explaining stuff fully. So, all right, so read first. This one first. .read. So basically, it returns one big string, just a big string. And when I say big string, I'm sort of talking about length. It means the whole file is contained as a string. So this is really the whole file as a string, right? So basically, we could split based on 2 conditions, and these 2 conditions are distinct in that it depends on what we want to do with them. We can split by the new line character, or we can split by the space. Okay, so when we read a file, all of this information is converted into a string with this information. Now, at the end of each of these lines is a new line character. Because remember, when we have a string, in order to contain all this line information here, let's say we have 1, 2, 3, 4. But because we're working in Python, I want to keep with this starting at 0. So we're going to say line 0, 1, 2, 3. These are now converted. Okay, these new line characters right here, these delineate these lines. Right? So the first line ends where this new line character is. The second line ends where that new line character is. Third line, or rather 0, 1, 2, 3. But you get the point. So with that, if we split by that, we now get a distinct number of strings in a list. So let's split for a minute. So we took a file, we did .read, and we split it by the new line character. Now we have a list that contains all of these strings, okay, 4 different list elements. Yeah, no comment here, of course. But so this is what we have now. So now to get the words, we could split by this space here, right? So there's a space in between. So it's just an empty string, it's a space. And if we did that, we'd get each word. So now each word would be a string in the list. So from there, I just want to clear a little bit of space here. Okay, what I'm trying to say here is that we start with this, right? So this is immaterial right now. So basically we split by the new line. So this is after we split by the new line. We want to split by word. We want every word in that file. Well, what we could have done, if we didn't care about the line information, we could have just split by the empty space. But let's say we have these lines, and now we need the words. Well, now it's gonna come up with a new list, and now it's gonna be split up by word. So each word here, right, and it's gonna keep going. So that's read in a nutshell. Anything else you guys want to know on read? If not, I'd like to move forward. Here we go. Alright, guys. That's read. Read line. So read line returns a string containing that line. String containing that line. So one structure we like to use with ReadLine is a for loop, because a for loop will go through the file. See, because let's say we read this file, we do a read line to this file, we're only getting this first line here. If we put this in a for loop structure, now we're iterating and grabbing each line. Now, one good thing about this is we're grabbing one line at a time, doing what we need to, getting rid of the unnecessary information as we go. In other words, once we use this line for whatever we need it for, it's being discarded and we're getting a new line. That's the good thing about this. The bad thing about this is we haven't captured all of the file information. We've opened it and we've gotten one line, which is why we have to use this with a for loop if we're looking to capture the whole file information, all of the file information. I don't really have too much more I want to say with ReadLine. You know, this is probably the least I've used this the least when programming. I use either read lines or read most often. I'm just gonna check the chat here and just make sure everything's going good. Okay. Yeah, definitely, guys. If you have a question, you could post it there, or probably better yet would just be to unmute yourself and ask the question. Okay. Read lines. So basically, it returns a list with each line as a string. And the good thing about this is we capture the whole file. And another good thing about this is, unlike read, remember we had to split read by the new line character to get the lines? Well, all the line information is already there for us. So if you find yourself having to have this line information inside of a list, which we could use read and then split it by new line for, why not just use read lines and capture that information just by calling read lines? So this is why I really like read lines. Now, if we take this and we use a for loop with this list, we could go through to each line, right? And one thing I wanted to append from before, well, one thing I wanted to say from before, I had mentioned that if that you could use .split, and you could choose to split it by the space or the new line. You would split by the space, I think, immediately, or the new line immediately, depending on what the task was. Because once you have it in list form, I'm pretty sure you can't split it. So just one quick correction I wanted to make on what I had said before. So split is done on strings, not on lists. Now, if you want to do it on each, what you could do is you could do it on each element within a for loop. But again, just make sure what you're calling it on is going to be a string. What you're calling split on is going to be a string. So that's one correction. Sorry for that misinformation there. Now we have one more thing that I really want to go over, which is write. So some people, or at least a few people, on their homeworks were printing and assuming that this was writing to the file. But in reality, the .write method with the string you want to write to the file as an argument, this is what we're going to use. So all the time when you're writing to a file, use this right here. Don't use print. Well, don't use print in assuming that it'll write to the file. You know, we know what print's used for already, for output. So, if we're going to write something, if we wanted to write a line to this file, we just write this. Now remember, with .write, make use of your new line. Your tab, this isn't probably going to show up on the test, but just in case, this is your tab, your new line. Remember your empty space. So you have all these, and remember, this isn't really a line here. I'm just indicating that to you now. But in Python, you just type it in, you just hit space in between these. And on your test, you just delineate it this way. It's not an underscore. Use these things here, depending on what you want to do. If you want to start writing it to that file on a new line, you would use this, so on and so forth. But I believe if you did it this way, I believe when you write to a file, if you circumvented writing over characters, I believe those characters would still be there. So in addition to append, I think you could do it this way, where you'll write to a new line. Not too sure if someone wants to double check that in the documentation. That would be cool. But I want to go over exceptions now. Now there are types of exceptions. So there are so many errors or exceptions you can run into. But I want to go over the types, and then on your test, if you're asked to figure out what exception something would throw, if any, you know, you'll at least be aware of the types. You know, because it's hard to go over every single exception. So we have overflow, types of exceptions. So we have overflow error, zero division error, IO error. And remember, don't mistake this. These aren't exceptions, these are types of exceptions. So, yeah, so these aren't like the specific thing. These are the types. Name error. Type error. So remember, when the exception gets thrown, it's going to say type error or something, but then it's also going to say the actual message to you of specific to your code. I'm going over just these general types of errors that you could run into in case you see it on the test tomorrow or the test this week. You know, in case you see and they ask what type of error will be thrown. Well, this should give you a better indication of why these errors are thrown. Type error, value error. Right now, obviously, type has to do with type, value has to do with value, a name would have to do with name. I'm going to go over these four. And remember, all this information can be found in your textbook as well as in the documentation. So this is an example of when you get an overflow error, as I mentioned before, trying to convert a huge integer to a float. That's going to give you an error, overflow error. You know Stack Overflow, the website. That's actually named after a Java exception that's thrown. An overflow has to do with memory. And basically, if you try to do something that's convert something that's really large, you know, your computer's not able to handle it. The memory's just not. It's just not the program. The program rather is not able to handle that. So Python. Zero division error when you try to divide by zero. So when you try to divide. By zero. So if tomorrow, on test day, you see, you know, y over 0, well, a zero division error is going to be thrown here. IO is regarding anything with input-output. Remember, IO stands for input-output. So anything to do with file input or output. And now, index error. Okay, when you try to index something out of the range, so an array has list has 3 elements. So we have 0, 1, 2. And you try to say, okay, well, I want that list at 3. That's going to give you an index error. Okay? So moving on, we're going to go over blocks of code now. So basically, all I'm going to show you is if, elif, and else statements, and differentiating between which code block each belongs to. The reason this is important for your test is because sometimes you'll be given a sequence of if, elif, and else statements, and you may have some sort of misconception as to which ones, or the question may be asking you which statements are going to be executed, and you would identify which code block each belongs to determine how many statements would be executed at minimum, and then you know, which statements belong to which code block. So you have your, sorry about that, you have if, elif, and else. And again, if you have any questions, feel free to unmute yourself and ask the question, or type it into the chat. I'll check the chat in a minute, just to see if anyone had questions. Alright, everyone's good. Okay. So basically, if, elif, else, this would be one code block. Right? Each code block can contain one if statement. So if you see if something, that's two code blocks. So one way you could tell a code block or block of code is that each if statement starts its own new code block. So I'll get more to that in a second after I explain this. Zero or many for this, I'm sure you know. Basically, you could have zero elifs or many, so 0, 1, 2, 3. You could have as many as you want. And else is either 0 or 1. Again, what does that mean? It means that else is invalid code. Right? So now, the next thing, alright, so we have this. So basically, why do we want to identify blocks of code? Let's say on the test you're given if, else, if, elif, elif, if, else. Alright, I'm just going to zoom out here just so you guys can see this. Alright, so here we go. So I'll zoom in so you guys can see it clearly at least. Okay. And so we have everything on the screen here. Okay. So guys, when we're identifying this, to determine what's going to be hit during the sequence of execution, we want to determine how many blocks of code there are. Right? So this is one block of code. Right? Now if else, that's another block, because remember, this else refers to the statement above it. So this is second block of code. If, well, this elif refers to this. This elif still refers to this. This is the third block of code. And then this is the fourth block of code. Right? So what we're going to try to do here is, see, so we had 4 if statements, which resulted in 4 blocks of code. Right? So basically, remember, each of these if statements signifies a new block of code. Anything below these if statements refers back up to that if statement. So if on the test they said, okay, if this was print this, print, so let's just say we had a bunch of prints, right? And then, so we have this one block here. Will this block always be hit? Well, only if this condition is met. Will this block always be hit? Yes. So this block will always be hit. So what I'm trying to go over here is, when you see things on the test, you're going to have to determine, for the multiple choice, you have to narrow down your options, right? So by determining the blocks of code and whether or not it's mandatory that they get hit is going to determine the answer to that question. So why does this always have to be hit? I'm going to actually change the color when I write this to show you, because it's kind of important. And just so, I'll switch up the colors just so we don't get bored with white and black here. We'll use red. This will always be hit. Why? Because there's an if-else structure, which means that if this condition is met, execute the code underneath indented within it. Else, meaning anything else. If this condition isn't met, then do this. It's impossible for one of these conditions not to be met, because this covers one condition, and this is everything else. This safety net wasn't put up here, right? We said if this condition, execute this. Down here, this condition was there. If this, so this covers one condition, this covers one condition, but or two or more. But the problem is it doesn't cover everything else. Whenever you see an else statement, assuming that it follows an elif or else, you have to hit one of those statements. You don't have to hit the else, but you have to hit one statement in that block of code that else belongs to. And this is definitely going to be hit. So now we're narrowing down choices. If we can rationalize that this condition is, none of those conditions are met, or these, we can eliminate these two blocks of code, and we can say, okay, well, the answer choice now is determinant upon these two being hit. So if there's only one result, assuming that there are print this value, now of course if you're printing an empty space, of course that's the exception. But if this says print not string, just print 5, and this says print, print second, and print first, string, right? Now we could, and one of the answer choices only has one thing printed. We can eliminate that because we know, and now depending on what these things are indented into, I'm assuming this is the program, okay, and that all these variables exist, all the variables and the conditions exist, and then we can eliminate that answer choice because two blocks of code have to print something, and this is assuming also that the else's have print statements. Again, if something's not printing, obviously if the output's only one thing, you can have that. So is everyone clear on that? If anyone needs me to repeat that, let me know. Okay, moving forward. Infinite loops and how to deal with them. So, infinite loops are one of the problems with while loops, mainly while loops. Infinite loops. Okay, and the biggest indicator of an infinite loop is while true. If you don't have a break statement within this, then this is going to go on forever. Because this condition after the while loop is determinant of when that while loop will stop executing. So why do we have while loops, or how can we solve them? And the answer here is there's two ways, two major ways that we can solve this. One way is that we have a condition other than true, right? Another way is that we have a break statement. But we have one more thing to add here. A break statement, be sure it will hit. And what I mean by this is, we can have a break statement. Just like I was talking about the if statements. If we have a break statement determinant upon, so we have if something, then break. Right? If condition, colon, underneath it, indented break. So this is what we're looking at right now. If this break. The problem is if this condition is never hit, this while loop will never break. So, like I was saying before, if we have an else and we have a break here, then we're guaranteed that one of the breaks will be hit. But that's one of the reasons. Another reason identifying code blocks is so important, or blocks of code. So, and a condition other than true just means that when we say this here, we don't say while true, we say while x is less than 5 or something. We give it another condition that's not true. Also, don't do while false. If you do this, then your while loop will never be executed. Remember, because you kind of said while false. You pretty much, if a while loop is a switch, right? If we have a switch and an outlet, think of it this way. While true, this is while true. We turn it on. But if for our electric bill, we don't want it to just stay on forever. We don't want a light bulb to blow out eventually. So we turn it off when we're done using it. While false pretty much starts out with this light switch turned off. Now we can say while solved or something. Let's say solved is a variable. Up here we say solved is false. And then somewhere outside, not in this while loop, but somewhere else, we say solved is true. That turns on this while loop. We can do that. But you got to think of this like a light switch, guys. Having it off all the time or having it on all the time is going to cause problems. You want to use the light when you need electricity, when you need light. We want to use this when we need it. Not, we don't want to be wasteful, but we also don't want to never use the light. So in a similar way with a while loop, I'm just trying to explain that. Be careful with true and false. Be careful with these guys because, using them with a while loop and not just a condition can get tricky. On the topic of true and false, remember one is true, 0 is false. In Python, there are a finite number of things that can be false. 0. Empty dictionary, empty tuple, empty string. Now that's not a space, remember, that's an empty string. Empty string, empty list. So any of these data types that are empty or 0 are false. And I'm pretty sure 0.0 is false as well. Anything else, including negatives, are true. And these should be, in Python, these are capital, so we'll just make them capital. So that's an important distinction to remember. If you think back to one of your first homeworks, it might have been the first one. Remember, it was put in the parentheses to make this statement correct. 0 plus 1 equals whatever. And you had to put parentheses there. What you were doing is you were making things evaluate to 0 so that they canceled out, right? So that was just to show you this. 0 and anything equivalent, any empty thing, or 0.0, anything equivalent to 0 or empty is false. Anything else is true. So what you could gauge from this is there's a lot more that's true in Python than is false. So there's definitely a finite number of false things, and there's a finite number of true things as well. But the number is so much greater that basically everything else is true. So you can imagine how how many more true things there are than false things. Okay. So I'll just check the forum just to make sure you guys don't have any questions. Cool. Okay. So let me check my topic list here. We went over files, dictionaries. Okay, dictionaries are next. And definitely, guys, if you want to see a topic covered, definitely post it to that forum, and I'll check it. I'll check it every once in a while, and we'll go over that topic then.
One quick thing, since we're on loops, can I ask a question about the loops?
Definitely.
A lot of times people have been talking about how do you get out if you have nested loops? Are you going to talk about nested loops, or are you going to keep talking about loops?
Sure. I'll talk about nested loops, sure.
Alright, well, very quick thing about nested loops is sometimes, like, the break will get out of one loop, but I don't think it'll break out of all of them.
Okay.
So when you're dealing with a nested loop, and you have to get out of it, well, one of the ways you can do it is you can put, you can use like how to get out of a specific amount of nested loops. Like, let's say you have three layers of nested loops and you want to get out of, like, let's say 2 of them, but not all of them.
Mm-hmm.
Now, if you want to get out of all of them, you just type in return, right? And then you just exit everything.
Right.
But if you want to get out of two, then what you got to do is you got to use encapsulation. You got to put the second two inner for loops inside a function, and then return out of that function.
Mm-hmm. That's one way to do it. Or you could have a break statement within this loop, and then when you hit that, there's a break statement here that's hit. Right, but you would have to. I think the point you're trying to make, Mike, which is a really good point, actually. Return terminates a function, and basically, so if you want to break out of a nested loop, and you want to break out of two layers of this nested loop, you have to use two distinct break statements if you're not using, because return would break out of all three. So Mike's saying you could either put these inside of a function and return out of that function so that you're just in this loop, or you could use two distinct break statements.
Mm-hmm.
Great point, Mike. And that also brings me to a print versus return. I want to, while we're here, I'm sure all of you guys that are here know this, but there still may be a few people in our class or in CS100 that still don't understand the difference between these. Print, right? It just display. It's for display. Display is a value. Return actually returns, for lack of a better word, it returns the value. Okay, and I'll explain what returning a value is, and terminates the function. Okay, now just some vocabulary. I'm sure all of you guys understand it, but just to be absolutely clear, nested loop means we have one or more loops inside of the other, which means our indentation here, one loop's indented, which means that this loop is going to execute all of its statements for every one execution of this loop. So if this loop has to go through 0 to 5, and this has to go through 0 to 10, well, for 0, we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 1, 2. Now, what I mean here is that 0 through 10, okay, 0, while we're in the 0th execution of this, 0 through 10 are going to be hit. While we're in the first execution of this, 0 through 10 are going to be hit. And that's what nested loops are. Now, the other thing I want to say was returning a value. Returning a value means we have this function name, and we have these parameters, and we pass these arguments in place of these parameters. We're calling this function. Notice there's no def here. We're assuming that defined function name, that this is valid because it's been defined somewhere else in our program. When we call this and when we hit this return statement within the function that we're calling, what return does is it takes, let's say we say return 5, this whole function call now gets replaced with the value 5. So what return does is it gives this function call a value. So the reason, if you just print that when you call this function nothing happens, the reason you have to print your function call, okay, is because print would display the value of this function, and the value of this function is determined by this return value. Everyone understand that? Everyone clear? If you're not clear, definitely ask, because this is one of the that's a big concept there. So definitely ask a question if you have it there. If everyone's clear on loops, nested loops, returns, and prints, I want to go on to dictionaries. Just because this is another topic you might see a few questions, or you may even have to use a dictionary in your programming question. I'm not sure, but just in case, we want to go dictionaries. Okay. Remember, enclosed in curly brackets. I believe there are two ways to make at least two ways to make an empty dictionary. We could set a variable equal to this, or I believe in Python it's dict. It may be dictionary, but I believe it's dict. D-I-C-T, open, close parenthesis. And that, in essence, makes this. Now, you could also double check that in the documentation or in the textbook if you want. But more importantly, a dictionary is, you have key value pairs separated by colons. Okay? Now remember, dictionaries are unordered. And one key thing to remember for the test, we cannot index dictionaries. That's very important because that has appeared on some tests, showing, you know, what is this code return? Sometimes like none of the above or an error or something. We can't index dictionaries. That's so important. So a lot of times, you know, people get caught up. You know, people may get caught up in the test, and they think, okay, this is valid because you're indexing something. No, not dictionaries. They're unordered. Anyway, more things on dictionaries. The key, immutable. The value, mutable. Right? Which means we can have a string as a key. We could have, like, those sort of types. A list, we can't have a list as a key. We have to have a list as, because it's a mutable data type, as a value. Remember, anything on the left-hand side of the colon, the element on the left is the key, element on the right is the value. And each key value pair, each key has to be unique. Because if we have two of the same key and we're unordered, how are we going to determine the difference? Right, the difference between those two keys? We can't. And remember, this isn't really going to appear in the test, I don't think. But the principle called hashing, this is important, you know, just to know as a computing concept, is that we have a dictionary with 10 elements and a dictionary with 1,000,000 elements. Searching through each of these will take the exact same amount of time. Why is that? That's because we're using the concept of hashing. We're identifying a key-value pair where the key is what we're referencing in this. So if it looks like we're indexing a dictionary, but we put a key value here, we're not. We're referencing the value at that key. So that's valid, don't forget. So with the dictionary name here and the key here, we get that value. So hashing basically means we're mapping that value to that key. We're not ordered. With a list, if we had 10 elements in this list or 1,000,000 elements in this list, time would matter. This would go a lot faster than this, the 10 elements. The shorter the list, the easier it is to look through. Because we're not it would be like flipping through pages. Right? So we have a phone book, let's say that's our list. We'd have to flip through the pages to find the person's phone number, address. Whereas a dictionary is sort of like just a computer database. You type in the name, you get the value you're looking for. You don't have to flip through all those pages. So that's why hashing is such an important concept in computing. Not necessarily for the test, but definitely in the future, you know. It's just a cool thing to know. And it'll definitely tie in with some of your majors, depending on, you know, if you're working with databases or whatever you're working with. That's definitely good to know. So lists. Well, one other thing I wanted to mention. I think you could use like dictionary, like dot keys or dot values. And I noticed on some of your homeworks, you guys used a for loop. And for I in, you know, this, and that's great because that's actually how you can iterate through a dictionary, even though a dictionary is unordered. So that was actually really clever. So cool. So that was definitely commendable for anybody that did that. Useful in the test, definitely. Lists, we went over those, so that's good. Dictionaries are good. Control structures. If statements, loops and stuff, we did that. Loop conditions, did that. Booleans. Okay, I want to return to the concept of a Boolean flag for a moment. Let's clear some space here. Actually, this way. I'll just go back to this. We'll just erase. We'll just put the black over it. So definitely let me know if you guys have any questions. I'll just check the forum to see if anyone posted up anything. Okay, we're good. Okay. Boolean flags. Concept of Boolean flag. This is going to be useful probably on your programming part, but some of these codes will be found in multiple choice. A Boolean flag just means we're using a Boolean, and we're checking for some condition. I'm going to use a gaming example. So we get to a locked door in a game, right? and it has all these chains on it. In order to unlock this door, we have to find the key. Okay? Now, this door is locked right now. So, if we go up to this door, we're going to start it out where locked is locked, we'll call it. Now, convention, this isn't necessarily, the convention isn't so important on the test, the concept is. But the convention in the future would be is, and then capital letter here with whatever the Boolean thing is. This is a variable name, though, so you could write whatever you want. But in like industry, especially in the game design industry, this is standard convention. Basically, is locked, and we'd set it equal to true. Right? And then we'd say if, in somewhere in our code, we have all these lines of code, and then we say if key found equals true, then somewhere down here we say is locked equals false. Now we're using two Boolean flags here. We just got to define this other one. We're going to say key found. I know I'm not following convention with this variable name, but just to illustrate the point, key found equals false. And remember, in Python, these are capital, so don't make that mistake. These would just be capital T and F for true and false. Okay, key found equals false. Now somewhere when he gets to the key and he finds the key, we'd say key found equals true. So that would be true. And then we just flags this because now that's sort of turned on. That's kind of like the switch I was talking about before. That's now turned on. That's true. So now in the code, wherever this is, wherever these conditions are, if this is true, then this is false. Right? So now is locked is false. Now the door opens up or whatever, and the player could go through. So that's just a quick illustration of Boolean flags and how we'd use those in sort of in a programming context. Now, in a Python specific example, if we turn away from the game example, we look at a Python example. If we were looking for a string in a string here, and we wanted to know when we found this, then exit. We would set a thing is found variable equals false, right, with a capital here, and then we'd say when we found it, we'd say is found equals true. And then that would signal that we found that, and that would determine whatever's going to call it in the code. So basically, we'd say while is found equals false, two double equals there. While at do this, then somewhere in there we say is found is true once it's found, and then that'll break out of this while loop, right? We'd say, and then because then we'd say if is found is true. Well, actually, it would break out. We wouldn't have to put a break statement because we have the condition. So actually, we wouldn't even have to put the break statement there. So that's Boolean flags. If anyone's unclear on that, definitely ask me a question on that if you need to. So moving forward, using empty lists to prevent repetition. So I said I was going to go over some strategies for the exam. One thing that is found a lot is preventing repetition and stuff. And a lot of you guys got a grip on this concept, but some people didn't, so I just want to go over this. Using empty lists, so one big strategy, which I think is extremely important, using empty lists to prevent repetition. Using empty lists. So what we would do, we have our main list, right? Let's say we have two variables. We have the main list, and this is what we're doing to answer the question, right? So this list contains the file, the lines in the file, or whatever. But we also have our copy list, or for better terminology, repeat list. Better naming convention equals this, and we define that empty list at the top. What this allows us to do now, okay, I just want to neaten this up just for regular purposes. Okay. Repeat list equals that. We have main list, we have repeat list. So we have, and now, so we're assuming we have all these lines in here. We only want to capture in repeat list the lines that are repeated, right? So we want to, anytime we do something, or if we're looking for certain repeat lines, we would store them here. What we would do then is this main list here would be like our clean list. So sort of, let's say we had the fox jumps the cat runs. Now this is a file. The fox jumps, and this I'm just going to pseudocode this, which for those of you who aren't familiar with the kind of pseudocode is just like explaining the concept or like using regular words. We're not doing code specific. We're not actually writing code right now to do this. I'm going to explain to you the method we would use in the code. You know, the syntax of the code would be, you know, I'm assuming you guys know how to do this. I'm explaining the concept of, again, using an empty list to prevent repetition. Here we go. Using empty list to prevent repetition. When we're going through this file, we would add each of these lines to the repeat list. Well, the way I did it here, this sort of implied that this would be the list of repeats. This would be found list, let's call it. Found list. And no space here, remember. And so we'd put this in, we put this in. When we got to this, right, we'd have that little check if it's not in the found list, do this. But this line's already in the found list. So we you know, avoid it, adding it to the list or whatever we do. But basically having this list to either store repeats, so to have the store repeats. So if it's already in this list, add it to this list, or if it's in this list, just skip over it. Whatever you want to use it for, we're eliminating repeats here. Now, I know I kind of explained that too clearly, so does anyone have any questions on that, or do you get the concept? Basically, okay, so I'm assuming no one has questions on that. Just one more time. We could either use the main, we have two lists. We could either store everything in one and repeats in the other, or we could store line by line in one, line by line in both, but then, or use one as like a check and be able to just skip over this line. So in that case, the second list may become immaterial. But I'd have to see an example just to make sure. But for this, we're basically skipping this line or we're adding it to a list, depending on what the question's asking. And using an empty list gives us the power to do that. Having a second list in addition to our first empty list, so that we're not just working with one list. We have our clean list that we're going to do whatever on to answer the question, and we have our other list that's going to store, that's going to be used for these checks and stuff. Next, I want to go over the turtle stuff, but user input first.
Quick question about the thing. So yeah, absolutely, like everything, yeah. But you could also use a dictionary instead of a list, because then if you want to only have one thing of one type, and then you could check the dictionary. I mean, it's the exact same thing, but if you check, you can use it. You know, you can have a dictionary and check if it's in the dictionary, and then if it is, don't add it. So, you know, it's another way of doing it, and yeah. It's exactly like the list way, but it would actually, because it's a dictionary, it might actually be a little faster. I don't know if it. So.
Yeah, it will be more efficient because of the hashing that's used in the dictionary.
Yep.
And another way, actually, good point you brought up, Mike. Another thing is use a set. I know we didn't really go over sets in class, but basically, if you want to use a set, that would eliminate repeats, because you can't have repeats in a set. So if you take a list that has repeats in it, you convert it to a set. Then you only left with one of each of the non-repeated elements. Now, I wanted to go over sets and tuples later on, but I actually want to, since that point was brought up, I actually want to look up sets in Python. I forget the exact syntax. It's similar to lists, but I think there's one distinct difference. Sets, okay. Basket fruit equals set basket. Okay, so if you see here, I'll zoom in on this. Right there, where'd that go? Sets. Here we go, sets. A set, okay. A set is an unordered collection with no duplicate elements. Basic uses include membership testing and eliminating duplicate entries. Sets also support mathematical operations like union, intersection, difference, and symmetric difference. Don't worry about that last line. Worry about that it's an unordered collection, testing membership and eliminating duplicate entries. I don't believe, what else? Curly braces can be used to create, or the set function can be used to create sets. Okay. Okay, now remember, don't use curly braces to create an empty set. Okay, that's what it is. Okay. So with a set, that's what it was. It was empty, the curly braces. So we have a list of elements here separated by commas, and you use curly braces. That's a set. Another way is set this. What they were saying was you can't create an empty set by doing this because that's an empty dictionary. You would have to use the set keyword, the set function here. So this isn't really going to appear on multiple choice, I don't think. I haven't seen it ever appear on multiple choice. But you can use it to eliminate repeats. Since we didn't go over it in class, and you may not have too much practice with it, I wouldn't. It's sort of like a last resort, but it's a good thing to know because let's say you totally blank out on how to eliminate repeats. You could just use a set, and then all the logic is taken care of for you. Once you convert that to a set, you would just have one of each unique element in the list. So it's good in that way. Now remember, it's unordered, so you could no longer find things at their index. Okay, so just like a dictionary, you'd have to have a workaround for that basically. But other than that, a set is good for eliminating duplicates. Okay, so just to review where we're at now, we went over a lot so far. There are a few distinct things I want to cover. I want to cover turtle, specifically solving turtle questions on the exam. I want to cover multiple choice strategies, and the same thing for the programming strategies. I want to cover user input, data type manipulation, I want to cover strings, errors, and I actually want to check Camtasia here just to make sure we're still recording and that everything is good. Okay, so we've been on for an hour and 12 minutes recording here so far. I'm still contemplating whether I want to break this up into 2 videos or just leave it as one. I'll just leave it as one for now, I guess. Tracing code. Common mistakes. Scope. Variable scope specifically. Print versus return we went over. Functions and parameters we went over. I'll review functions and parameters. So functions and params. And sets and tuples, I'll just review tuples because we went over sets just now. Alright, does anyone else, you can unmute yourself if you want, and if you have any other topic you want me to add to this. So any other topic that you guys were unsure about for Thursday's exam? Okay. So let me know if that changes, but for now we'll just go through these one by one. The turtle question. So the turtle programming question, this is usually, well, there's always a turtle programming question, unless they decided to change it. Common turtle questions, or past turtle questions, because they usually don't repeat. Past questions have been this. This was one of the more crazier ones, but it's actually manageable, and I'll show you how to do it. Drawing a rectangle. So starting with a rectangle, turning it, making a new rectangle, all different sizes. So everybody should get a perfect score on the turtle part, which is 20 points. Because what I'm explaining to you is that turtle, all the turtle question is a pattern. You're going to want a for loop. You're going to want to make use of all the parameters. So in every turtle question I've seen, it could be solved in this exact way that I'm about to show you. Define something, all the parameters they give you in here, separated by commas, obviously. Put the pen down, t.pen down. What this takes care of is they're going to say something like, don't assume anything about the state or orientation of the turtle. What that line is indicating you, just remember when you see that line, t.pen down will be the first line after you define the function. If you put in this line, you'll get full points for that part because that's what for that specific requirement. Don't assume that the state orientation turtle. It just means put your pen down first because in a complex program, remember the user could pick the pen up, right? If the user picked the pen up, and then your program was called, it wouldn't work. So that's why when you're writing this function, right? You're writing this function, everything's indented under the def keyword here. You're going to want to put this pen down to make sure to be safe. For loop, and they usually give you a number. If they specify a number, you could put in for range, but I think it's going to be for range, for I in range, and they're going to say like num times or whatever. They're just going to give you some sort of, it's going to refer to one of these parameters up here that means number of times. Okay, and what you're going to do in here is you're going to do one iteration, one step, and set up for next step. Being mindful of the pen orientation. So if you do this, you will get 12 points, I think, because defining the functions, assuming the pattern is right and everything, and your code is right, this is how you get your 12 points. You define the function, use all the parameters they give you here. Put your pen down, use a for loop for the number of times that they specify, usually with range. Set up, go through one step. So for this bullseye question, you'd either start from the middle and work your way out, or you'd start from the outside and work your way to the middle. Doesn't matter which way you do it. But basically, you would draw one circle and you'd set up for the next circle. So what I mean by that, to give you a simpler example, and yeah, so to give you a simple example, first I'll make one point at a time. First, we have this. This is our pattern. Inside this for loop, you would do this: draw one line, leave one space. So your steps would be the pen would be down, go forward this amount, which would be like line length or whatever parameter they gave you, pick your pen up, go forward for this amount of space, which would probably be reflected in a parameter they gave you, put the pen back down. This is the body of your for loop there. Combined with the number information that they give you, this will complete the pattern. The one exception, okay, not Python error, I'm not saying exception in that sense. The one exception to the rule that I've specified here for the patterns are these angle things, where they want you to tilt things on angles. Now, you've already had practice with this, but basically the angle would be a parameter. Okay, so there's two things. The two tricky things are angles and changing size dynamically. So dynamic size, pretty much, changing size. Angles would just be a parameter, and you would just go t dot right, however much, or t dot left, however much, the value in here. Changing size, you would have to somewhere say, you know, that you'd have to multiply like whatever your size thing was usually by I if you're in a for loop, or whatever variable you specified in the for loop. You're going to multiply by I, or whatever they tell you. So if they say incrementally, that's usually what it is. And so those are only two tricky cases. But other than that, then you just got to be aware of calling the function. So then, for the other 8 points, because usually that's 12, and now you want 8 points. I just need to clear space here.
Hey Robert, is it safe to use t.home?
T.home?
Yeah.
I'm not. What does home do again? I'm not sure.
It puts a throw back in.
Oh, the state and orientation that it was left in, right? That it started in.
Yeah, 0.
Yeah, 0. Yeah, you could probably use that. I've personally never done that, but the way that I handle their thing is I just put the pen down at the beginning. So proper coding practice would be to put it in state orientation which you found it. But I don't think that's a requirement for the test on Thursday. But if you want to, you can use it, definitely.
Alright,
yeah, what's up?
No, I said thanks.
Oh, okay. Yeah, sure. Okay, so, what else? Yeah, you can use t.home. So, basically, I was saying the points of, okay, so the other thing you wanted to do would be calling the function. So import turtle, this is usually part B, import turtle, t equals turtle.turtle. Don't forget these parentheses here, s equals turtle.screen. And then you want to call the function, so function name with the arguments, that's how you do it. And that would be perfect 20 out of 20 on that part of the test. The reason I say you should get a perfect score on that part of the test is because, like I said, it's always a pattern. The other coding questions are a little more complex, and they don't necessarily follow an explicit pattern every single time. I can say there'll probably be one on files. They'll probably involve string manipulation or list manipulation, things like that. But other than that, they could always do some sort of little thing here or there to make it different. The turtle question, on the other hand, is pretty much there's only so many ways you could ask someone to do a pattern, and no matter what the pattern they give you is, if you follow those steps, you'll get most or all the points. Now I just realized that I deleted the list of things I told you guys I was going to. Okay, here we go. Went over turtle. Multiple choice strategies. So I'm actually going to delete this stuff, but not that list, hopefully. Okay. Multiple choice strategies. So talking to a lot of people during office hours, I realized the main part of the test that's messing you guys up is multiple choice. So basically, and having talked to you guys, or some of you guys as well, multiple choice is the part that was messing you up. So basically what you're going to want to do is trace the code. Now remember, tracing involves making a table. I'm not sure if you'll be given a table on your exam. There was discussion at the meetings about giving you guys a table for each question to trace the code. Now, whether or not that's going to come into fruition, I'm not sure. But you could quickly sketch out a table. You'd have your this would be your variables on this side, and these would be the lines. And this is how you keep track of what that value of that variable is for each line. So 0 and 0. Okay, here we change it to 1. So for all your variables, and then at the end here, you would have a nice little clean list of what each variable is at the last line of the program, the last iteration or whatever. So this is your last thing, and then the thing would say, okay, print I comma r. Well, what's that going to be? Well, it's going to be I comma r. So it's going to, or print I. Okay, well, we're going to get I from right here. Well, so whatever we determine, as long as we did our math right and followed along in that way. I know they like to say cease to be human on this part of the examination. In other words, you want to totally execute like a computer would. You want to, for each thing, just do the step. Don't think about it, but just do the step. Because sometimes your gut feelings, they kind of, they could always, mess with you. So you want to use a specific sort of approach to getting these questions right. So in terms of that, that's the biggest piece of advice I have for anyone struggling with multiple choice. I could share my method the way I did it. I'm not sure if it's the most ideal way to do it. They say that tracing code is the best way to do it. When I used to when I took this class, the way that I solved the multiple choice questions, I'd spend time just looking at the program, and I actually know that there's other TAs that actually have done this as well because they've described it in meetings. So they give you like for this, and it's a block of code, right? I look at that code, and I make sure I just get a general sense. I just glimpse at it for maybe 30 seconds to 2 minutes, depending on, it all depends, and in that time, I'm just understanding what's going on. I'm looking at things such as data types, variables, control structures, so loops, statements, if statements, break statements, all that stuff. I'm just taking all that in. Then I go to the side on my piece of paper and I start writing down notes to myself. Be careful of this. Oh, this is indented here. Be careful. This is a nested loop, or this is whatever. Next, what's gonna happen is, oh yeah. So then I just go through and I do something similar to tracing the code. I wouldn't necessarily draw the table, but I would keep track of each variable's value through that. And then I'd see if I could eliminate choices, or if the choice I had was right there. And I definitely check it over. I try not to change my answers after I choose an answer, but I try to only choose an answer once I've done this whole process of looking at the question, understanding it, reasonably assessing all of these things, and then actually tracing the code. But I'm sure there's other approaches that are better. Next, yeah, so that's basically, if you really can't get a multiple choice question, like if you really don't understand what's going on, of course you could guess because you don't lose points for incorrect answers. But I would say have some understanding of what's going on in the code, because if you don't have some sort of understanding of what's going on in the code, you're doing yourself a disservice. And I'm sure all of you guys have the tools and techniques to get 100% on the multiple choice. But they are tricky. I'm not going to, sugarcoat it. They are tricky questions. I'm sure even people that know Python or have taken the class, if they had everybody sit down and take one of these exams, I'm sure everyone once in a while would miss a question or two. Just because that's the way it's set up to trick you. It's set up for that. But moreover, it's not set up to trick you. It's set up to trick the people that don't have a firm grasp on everything and that aren't aware or alert on test day. Programming strategies. I take a similar approach. So programming questions, you've noticed, it's like a paragraph. I take my pencil or my pen. I circle the keywords. I circle anything that's going to indicate things to me. I underline stuff. I make a square around important information or rectangle. I do all the things. I don't just do one specific. I don't just do a circle or an underline. I do all that. I really mark it up, and I read the question at least twice. After I've marked it up and read it, as I'm reading it, I also make notes to the side. So okay, there's a file question. It looks like I'm going to have to use read lines here, or the most efficient way to do this one would be read lines maybe, or read or whatever. Don't forget to close the file. Another thing, if you're studying something, like one thing I found that's helped me is if I know, for example, that I always forget to close the file, as soon as I get that test booklet in front of me, I'm going to the last file question, or when I get to those questions, and I'm writing don't forget to close the file. I'm circling that, and I'm putting an asterisk on either side of it. And when I get to that question, when I'm reviewing the test, I'm making sure that I close the file. So that's one big thing for me is I circle stuff, I point stuff out, because some of it, well, none of it's really nonsense, but some of the sentences or words are more important than others. You want to point that out, and you want to have these notes. So I'll make myself a little checklist of this. These are all the steps I have to do. Also, I take the scrap paper, and I write my code just as if I was writing it for real. The reason I highly recommend, unless you're in a time crunch, you write the program twice. The first time you write your answer is on the scrap paper. The second time you write the answer is transferring it from the scrap to the regular question sheet. The reason you do this is because I can't explain how many times on coding final exams I've written something on scrap paper or on the wrong page by mistake. So I've had to rewrite the code, and I've caught mistakes. It just happens because you're so focused on it that you catch your own mistakes when you're looking it over. That's one of the reasons in the programming industry they have other people read your code, because sometimes you get so attached to a specific problem in the code, you overlook something, and by someone else checking that, they're able to catch those mistakes. But unfortunately, you don't have anybody else to look over your exam, right? Because that would kind of be cheating. So what you do is you write it on the scrap, you transfer it to the test, and in that way you catch your mistakes. Hopefully, that would be my recommendation. And just
right. So as you said, the whole idea is, yeah, if you're looking at one thing, just that one thing, you probably won't catch the error. But the way I like to do this is I like to go through the test, and I like to go through it at least like once or twice, like at least 2-3 times, because on the first run, you do them all, but you might get something wrong. You check all your work again with a fresh eye. You might spot the errors that you missed. So exactly like you said, on the first time you might not get the right answer, but if you do it 2 or 3 times and you still get the same answer, it's probably right.
Exactly. I agree with Mike 100% that exactly. You have to check your work, and I think also rewriting the code, like you said, like checking your work is important. And I think rewriting the code, the actual physical act of taking the pen or pencil and transferring it line by line, you're just gonna notice maybe an indentation mistake, maybe you missed a colon,
absolutely.
And you're just gonna. What's up?
Yeah.
What do you say, Mike?
Absolutely.
Oh yeah, exactly. Yep. That's. Mm-hmm. Yeah, so that was the multiple choice and programming stuff. So we got rid of that. User input, okay. I'm sure you guys know user input, but just to be sure. So user input. Variable name equals input, and this is the message. This message is going to be displayed to the user. Their response to this message is going to be taken as input, stored in here. As it's written now, the information taken in will be a string. I'm going to say that again. The default of the information typed in by the user will be taken in as a string on input. Which means if the user gives an input of 5, it's read into the program as string 5. What does that mean? That means that if we wanted to evaluate to integer 5, we have to either do eval input that or int input that. Safest way, use eval. Because if the user puts in 5.0 or 5, it's going to be that data type. Well, not safest way. It depends on what you want your program to do. If you want your program to take the data the user gives it and change it to that exact data type, you use eval. If your program is only written to work with ints, then use this. And in future classes, you're going to learn like try-catch blocks and stuff. We covered that. You're going to learn just how to prevent, so how to force the user to give you the information that you want. If they don't give you an integer, it tries to convert it, it'll give you an error. So in that sense, in future classes, you're going to learn how to circumvent that and say, tell the user, please put in an integer. I think we went over some of that too, and you guys know how to do that. But if, for now, for all intents and purposes, you want to remember, you could either force an integer if your program only works with integers, or you could evaluate to the data type that you want the user's input to be, or that the user's input is, rather. I don't feel there's much more to cover on user input. If you know that and you know programming logic, there's no reason why you really shouldn't get a a good score on any input question. There's no reason you should miss an input question. Really, the biggest reason people lose points is either misunderstanding a concept, which is what this is hoping to prevent, or they were like tired or not focused, and the question was really tricky. So I can't really help with tired or not focused on the day of the test, but I can help with clearing up the misconceptions that you might have on the day of the test. Data type manipulation. This directly ties in with the user input thing that I was saying, where okay, the user gives you the input is given as a string, but we want to force it to evaluate to something. So we use eval or int. That should be a. So whatever we want to use. Moreover, data type manipulation for string concatenation. So if we have print 5 plus string, in Java this works. Of course, we have the semicolon then if it was Java. In Python, this doesn't. Python does not, okay, I'm going to say it does not, it doesn't force string. Right? It doesn't force strings, which means, there's a better way to say that, but basically, in Java, if you're concatenating something to a string, it forces everything else into strings. So it's like a safety net. In Python, that doesn't happen. So in Python, we're responsible for saying str5 plus that. See? So we're responsible to make everything strings, so that when we want to concatenate something, that we're using for concatenation, rather. So in a similar way, if you have a float and you convert it to an int, a float and convert it to an int, yeah. So int of the floating point value, because your program works with an int, then that's what you have to do. So be very, very mindful of data types. And of course, guys, if you have any questions, definitely unmute yourself and stop me or if I'm going too fast. I'm just assuming right now that most of you guys, don't feel bad if you have a question on it, but I think most of you guys know this stuff. We covered a lot of this stuff the first few weeks of class, so I assume you have a lot of practice with it. Now, in contrast, scope is something you might have a question on, because scope is something that we just recently covered, and that's something I want to go over. I just want to change the color here just to keep it somewhat interesting for you guys. Sometimes that's another thing too. If you're taking notes on this and you're reading a lot of notes, one thing you can do is highlight in different colors. The reason is because, like, I don't know, it's something about your eyes and your brain that when you see things in different colors, it like makes you remember stuff better. So that's just a quick tidbit of information there. Okay, so what was it? I'm saying scope. Okay, so scope. Local versus global. Local versus global scope. If something is defined within a function, so we have define function. Okay, so we have x out here, x equals 5, and then inside of the function we say x equals 0. Okay? X equals 0 when this function is called. When this function is terminated, meaning when the function call is terminated when it hits a return statement, x ceases to be 0. For the duration of this program, of this function call, x is 0 for this function. I want to stress that this global, if this is the computer program, this global variable is what is identified as the universal value of x. Within this function, we have overrode that sort of, or I don't know if it's technically overriding in the context of the program, because don't forget, overriding is actually a thing you're going to learn in Java. But it's sort of, it's the same concept where you have a variable here, and you're giving it another value for this specific purpose. Overloading in Java just basically means that we have like different functions, or we have functions like the same name but different parameters, or sort of stuff like that. But basically, I'm not sure if I explained that too well, but we're doing Python. So basically, for the context of this is global, right? This is local. If we have another function here, this is local only to this function. 0 is only local to that function. So everywhere else, even in this function, x is 5. One way on the test that may appear on the multiple choice is inside of this function, okay? If we have the global keyword, everything changes. Global x equals 0 means x is 0 for everything once this function is called. So please make that distinction that the global keyword actually makes that the global value. So that means that when this function's called, even if you have x equals 5 up here, when this function's called, x equals 5, x no longer equals 5, now x equals 0. It's the equivalent as if we were outside of the function and reassign the value of x. It will be equivalent to coming down here and saying x equals 0. At any point after this, x would be 0. Global is the equivalent of that inside of the function context. Meaning, inside of a function, we use global to affect this in the same way that we would use it outside of the function. So once again, even after the function terminates, x is 0 now. That's a big distinction you need to make. Because one multiple choice question might have that. I don't know. I think when I was taking the test, back when I took the class, many semesters ago, I think there was one question that asked about global. It asked about scope. So just be very mindful of that. Now, I just want to check my email real quick just in case someone is having trouble logging on to our... let's see. Okay, so good thing we checked. 2 people are having trouble. So actually what I'm going to do I think there's a way for me to invite them to a Google Hangout session. It's basically what I'll do. I'm just looking for the invite button. Hey guys, does anyone, if anyone knows where how I could like invite a few people who are having trouble like coming on, you can definitely let me know if you want. You know what I'll do? I'll actually send this link. I'll email him this link.
Robert, you click the corporate icon
Which one?
on the upper right-hand corner. The building?
Upper right-hand corner. Right? Upper right. Which one? This one?
Yeah.
You saying this one? Okay.
Yeah, that one. Yeah, that one.
Oh, cool. So, Brian Luong.
I'm already here.
Okay, I thought that might have been you. Okay, so you're here. But Mia Marshall's not here, right?
I don't know. Yeah.
Okay, so we'll invite her just in case. So we'll invite her. Okay. So I guess I'll have to respond to that. Cool. Okay. Probably should have checked that a little sooner because they missed some of the review, but I guess there's nothing we can do at that point. So everyone can see this screen still, and we still have. I just want to make sure the video is still recording. My two biggest concerns are you guys can still see the review, and we're still recording the review. Okay. Now I don't know if YouTube has a limit of how long a video could be before they, for them to allow it, but I've put up to I think over an hour, so I'm pretty sure we're okay with that. In terms of topics, we covered scope. Strings, we covered strings. Errors, we covered errors. Tracing code, we covered tracing code. Common mistakes we'll go over. Obviously, I can't get to all the common mistakes, but anything that crosses my mind is a common mistake. That's kind of what I was trying to point out common mistakes all through the review. So I'll try my best to do more. Functions of parameters, we reviewed that. Passing parameters and tuples. Okay. Remember, guys, I'll use a tablet for this. So a tuple, separated by commas inside of parentheses, immutable. And now I'll actually refer to the Python documentation for a tuple. Just because tuples are a little less frequently covered, just want to make sure. Let's see if anybody... Okay. Just seeing if anyone responded to the email. Let's see, tuples and sequences. Here we go. Tuples. Closed in parentheses. Okay. This is the important part. Although tuples may seem similar to lists, they are often used in different situations and for different purposes. Tuples are immutable and usually contain a heterogeneous sequence of elements. Okay, so different sequence of elements that are accessed via unpacking or indexing. Lists are mutable and their elements are usually homogeneous, meaning this like of the same type or the same, and are accessed by iterating over the list. Or homogeneous in the sense, I believe, or homogeneous would mean for the same purpose, I would like to say. Because, of course, you could mix and match types in lists. But a special problem is the construction of tuples containing 0 or 1 items. Empty tuples would be constructed by an empty pair of parentheses. A tuple with 1 item would be constructed by giving following with a comma. So, hello, and then comma. So I'm just going to zoom in here just so you guys can see. Here we go, right here. You just follow it over the comma. So it's not very intuitive, but it gets the job done. Okay, that's all I want to say on tuples. Again, because I said, like, how infrequently tuples are used, how you probably won't see any on your exam. I just don't see the point. Aside from saying that general information, I don't see the point in even continuing. The only other thing that you should know is that these are immutable, so they can be used as a key. They can be used as keys in dictionaries. Other than that, I'd be very surprised if you guys saw that on your test. You very well may, but I'd prefer to focus on stuff that is like practically guaranteed to show up. And of course, I haven't seen the test, so I don't know what exactly will show up, but my best guess would be a lot of the stuff that I've covered. That's why I covered hopefully those 4 topics. So the last topic that I had planned for our review is common mistakes. And you guys can feel free to ask more questions or add more topics. But for all intents and purposes, for what I was, when I was going through this stuff, I found that this would be something we'd want to go over. Common mistakes, misuse of parameters. So basically having parameters here when you define a function, and either giving specific values at this point or during the function call, writing those parameters again. Kind of the exception to this would be t, turtle, maybe if you're passing in t instead of t down here. Just be very careful. Understand parameters and arguments. And of course, stop me if any of you are confused or have a question, definitely stop me and ask. Common mistakes, string concatenation. We have this concatenated with 5. That's not going to work. But this concatenated with 5 in the string context would work. We went over that. Common mistakes. Okay, strings are immutable, right? So if we have a string str1 equals this, and then we have str1 plus this, right? Can that happen? Can we add something to a string? Strings are immutable, right? So we can't change them. But this is actually what tripped me up when I took the class. On one of the questions on a test, actually. I think it was midterm 2. Or it may have been midterm 1. We have this and we end this. Yes, we can, because in Python what happens is when you concatenate a string, you're reassigning, so str1 equals that. You're reassigning that value. You see, so when you're appending something to that string, Python's making a whole new string based off the concatenation you did. It's not just changing that string value. The string you gave it no longer existed, and it's replaced by that concatenated string with this information at the beginning, obviously. Assuming you did a proper concatenation. What else? Common mistakes. Printing or returning at the wrong points. Printing or returning with internal functions. Remember, turtle is we're drawing in that. We don't return or print with that. Printing or returning and thinking that that's going to substitute for .write won't work. Guys, so remember, identify a question based on we're working with files, user input, and remember, file, input, output. So distinguish between file, input, output, which is file I/O, or user input. I'm going to say user input, program output, sort of. Although, yeah, I don't confuse anybody. Turtle. Lists and strings. List strings. What else? Just like that, you just want to distinguish what type of problem am I solving, because that's going to determine .write. You wouldn't use .write if you're dealing with strings, unless you're dealing with strings in the context of files. You wouldn't use you wouldn't use the input function when you're dealing with files unless you wanted to use it to input something. So be very mindful of what the question is asking and what you need to do in terms of that. What tools you need to use from our little toolbox here that I've shown you. All these method stuff. It's all tools, and now you're just using these tools to solve problems. That's about all I have for a formal sort of thing. I don't have any more topics or things planned. If you guys want to ask questions, or if you have any additions that you want to make, let me know. I do have some time, so I mean, if you guys do want to ask me anything or anything, I mean, you can unmute yourself and say it, or I'll check the forum as well if you want to post something onto this little Google chat thing here. I'll also check to see if anyone else. Okay, yeah, it doesn't look like anyone else is signing on right now. Yeah, so definitely, guys, do you guys have any questions? Anything else you want to go over?
No.
Okay, what about the other people? Anyone else have anything?
Nope.
Okay.
Covered everything.
Covered everything? Okay. Well, that's good. Alright, what about Mike or Dorothy? Do you guys have anything you want to add?
This is all gonna be on YouTube, right?
I'm hoping. I'm gonna take the video. Yeah. Well, assuming no technical issues occur. So, okay. So